Hello, we are Seul, Alexandria Lydecker, Ryan Reed, and then Amy Tony, and we are going to be talking about calculus in veterinary medicine, treating parvovirus. So what is parvovirus? A quick introduction is that it first emerged in the United States, Europe, Asia, and Australia in 1978 when a virus similar to feline panleukopenia virus crossed over from cats to cause a new type of disease among domestic dogs. This was most likely spread through the eating of feces by a dog that was produced by a cat. And within 2 years, the virus had spread worldwide, killing thousands of dogs and possibly infecting millions more, which is quite a big problem. The primary way to prevent canine parvovirus is through 3 sets of vaccines set between 3 and 4 weeks apart that puppies receive between the ages of 6 and 16 weeks. And then also the incubation period of CPV2, which is another name for parvovirus, is between 3 to 7 days, with common symptoms including vomiting, loss of appetite, lethargy, depression, fever, and diarrhea.
So why parvovirus? So parvovirus, we chose this for our project because it is a rapidly mutating virus that is very prevalent in everyday settings. And despite a vaccine being made, outbreaks still occur because owners fail to follow through with the vaccinations for their pets. So it is important to keep the public informed so that our pets are kept happy and healthy and eventually eradicate parvovirus.
So here's the problem that our group decided to solve for this project. The table on the left displays the number of yearly parvovirus cases in the United States since its introduction to the country in 1978. And here, X represents the year and Y represents the number of cases from that year. 3 years later, a newly developed vaccine against parvovirus was developed and implemented to the public, and numerous puppies in the US soon began to receive this vaccine thereafter. A large part of the data for years 1984 to 1990 was lost due to a corruption in the data server and cannot be recovered. How can the incomplete data be used to draw the most accurate conclusions about the virus and the effectiveness of the vaccine? And for part A, we will predict the number of dogs that were infected during the years where the data was corrupted. B, compare the infection rates for parvovirus before and after the vaccine implementation. C, estimate the total number of dogs that were infected since parvovirus was brought to North America. And first, we will tackle part A by finding the regression for the current data set.
Okay, so when finding the regression, what we immediately found out is that we wanted to model the entire data set with one polynomial function. To do this, we started off by making the data and the x values years since 1978 for simplicity of the function. And we immediately went with a 3rd degree polynomial because we believed that it would model it best with 2 inflection points, as we noticed in the data. Then going on to the next regression, however, we noticed that there was actually only really 1 inflection point with the derivative switches signs down in the lower point, and therefore it would be best modeled with 1. However, once again, we noticed that there was still an issue with the data, and we thought that it would be best modeled actually by 2 separate functions, one before pre-vaccination and one post-vaccination. To that end, we had 2 different regressions, one of which was a square root regression, and the other of which was an exponential function regression that was modeling a decreasing exponential function. So now going on to that, we now took the derivative of these regressions equations and compared the values from pre and post-vaccination. So first, when looking at the derivative, we have, of course, in the first line, the derivative itself. And then when taking the derivative for the constant rule, we found that because of the fact that there's a constant at the end, we just knocked it off with it as that turns to 0. And then for the derivative of the rest of it, we found that we would just be using the power rule, which would make the derivative relatively simple, to which we just plugged in the number 2 as it represented the final point before vaccination was implemented, and we got about 183,000 cases per year. Now looking at the derivative of the post-vaccination period, we once again wrote out the equation and did the derivative on this one. In this case, we used the chain rule rather than that of the power rule. We also did still use the constant rule as it does have a constant. And what we found is by plugging in 5, which was 3 years after the vaccine was implemented to mirror that of the pre-vaccination period, we found there was about negative 78,000 cases per year.
So by comparing the rate of infection 3 years before the vaccine and then 3 years after the vaccine, we can clearly see that the infection rate did in fact decrease as the slope goes from a positive slope to a negative slope.
And finally, we will tackle part C of the problem by using integration to model the total number of cases in the country over the years. And so first we started with taking the integral for the pre-vaccine infection rates. And here we used the model that we got from the regression to take the definite integral from 0 to 2. And here we see that we use the reversed power rule to do so. And finally, we got net change for the year from the year 0 to 2. And we had to add 354,000 from year 0 in order to get 1.8 million as our total cases. And for the post-vaccine infection rates, we again took the integral of the model and we took the definite integral from 2 to 17, and we had to use the reverse chain rule, which is also U substitution, and ended up getting 1.6 million as our total cases for post-vaccination.
So in order to find our overall total cases, we took that definite integral from 0 to 2 of the function f of x, and then the definite integral of 2 to 17 of the function g of x in order to get our overall total cases as we were adding the two areas under the curve together. So that resulted in us adding 1.8 million and then 1.59 million together to get around 3.4 million total cases of parvovirus in the US since 1978. However, we did realize that because we were taking that total cases by taking the integral, we could also use that to find the total of cases in the amount of data that we had lost from 1984 to 1989. So we did this is that we started off once again with the original function, and we followed the steps that we had taken before to take that definite integral with our various integral rules. However, instead of keeping the interval that we did from 2 to 17, we limited that to just the years that we had lost, which was 5 to 12. And from that, we were able to find that in that gap year, there were in those gaps of years, that was 339,000 total cases that just had the data had been lost for.
Okay, for the first part, we used regressions to find the functions for these different models, modeling both the pre-vaccination period and the post-vaccination period that we used in order to fill the hole in the data.
And then by comparing the derivative 3 years before the vaccine and the derivative 3 years after the vaccine, we could see that the vaccine was very effective as it dramatically decreased the infection rates.
And lastly, by taking the integral of the post-vaccination function for the years 1984 to 1989, we found that the number of infections during the gap period was about 340,000, and the total infections from the entire period, 1978 to 1995, was about 3.4 million.
Interestingly, this because the rate of infection is so much greater during the pre-vaccination time, despite being only 3 years, shorter than the total number of infections in that period. 1.84 is greater than the infections from the entire 15-year period after the vaccination, which does mean that from the initial thing that we were looking at, that the vaccine implemented actually does work a lot, and that if we continue to vaccinate our pets and we continue to make sure that people are using their vaccinations and fitting with the period, parvovirus will be taken care of, your pets will be safe, and hopefully after a while it will eventually be eradicated. Thank you.